Hello, everyone, and welcome to Africa Fire Mission's weekly virtual training session. My name is Mike. I'm a project coordinator with Africa Fire Mission, and I'm so happy you all took time out of your schedules to join us today for training. Today, we've got a great instructor. He's taught with us before. James Nyadwe is here with us. He's going to be teaching us about some building construction. If you stick around for at least 70% of today's training, which is usually about 45 minutes, you'll receive a certificate of attendance for today's training. If you keep your eye in the chat, I'll post some information about how you can check out this training as well as all of the other trainings that we've offered so far this year, and a way for you to earn a certificate of attendance for those as well if you weren't able to join us live. Before we get started with today's training, I'm going to pass it over to Jose, Africa Fire Mission's fire safety advocate, for a few words of encouragement.
Thank you so much, everyone, for joining in. Thanks, Chief Mike. Thanks, Mr. James Nyadwe, for showing up, and for you to actually show up in the training. Asanteni sana. Today, I want to be vulnerable to you guys. And my vulnerability is because basically to encourage us to be talking about our issues, especially about the PSCD we go through in our lives. So with my condition, with what I have, as you can know, I got burns when I was 4 months old. And I usually have some relapses from time to time, and some moment of low self-esteem shows up. And just last week, I had a moment of low self-esteem. And really, the low self-esteem means you have an opinion about yourself. You know, I was just feeling like, hey, now what are people thinking about me? What am I mean, when I'm walking to a place, guys are looking at me, and I really felt low, and I couldn't be able to even have that feeling of going out. You know, and I've had these relapses now. I get a relapse for about, in 10 years, I can get like one relapse, you know, and they really get heavy. In fact, I'm just from recovering from it some few days ago. And I went to the internet to check what I can do to help myself. Yeah. And I came with these 3 things. Actually, there are more, but I'll just stick to these 3. And one of them is recognize what you're good at. Yeah. And for example, what do I mean by that? If you love cooking, if you love singing, if you love to do puzzles, or talking to a friend, you can talk to them. Not necessarily about what you're going through, but just general talks, you know? So that really helped me out. Number 2, build positive relationships, you know, whereby you can be vulnerable to your friend and you can spend more time with people who value you and who you feel you add value to them. And the last one is be kind to yourself. I wasn't kind to myself. I was really beating myself up, you know? So be gentle with yourself at times when you feel like you have low self-esteem, you know, and then give yourself a pat on the back. Tell yourselves, hey, you're going to be good. Yeah, there are low times and there are high times, and this is a low time. But get up, fall down 7 times, get up the 8th. So I just felt I need to tell you that, and just to encourage you, don't feel low, talk to somebody, and make sure you build relationships. Thank you so much. Back to you, Chief Mike.
Thank you, Jose. We always appreciate you being here and taking your time to share some of that stuff, even when it's really personal. That can help us out quite a bit. Without further ado, I'm going to pass things over to James. James is joining us. He's a local son from Kenya, but he's joined us today from Somalia, so we hope that everything's safe and sound there. James, go ahead. Take it away, sir.
Thanks a lot, Chief Mike. Thank you, Jose, and thank you for everybody else who's tuning in from whichever part of Africa you are, or if you're out of Africa. So welcome to today's topic. So I'll just go ahead and share my screen really quick so that we can get on with it. Now it's a bit of a, it's a little of a kind of a stretched out one, but we'll just work on it kind of slow and we just go through it. If you have any questions about it, please, you can wait till the end, then you can ask, but I'll try and run through it as efficiently as I can. So we're talking about building construction in relation to the fire service. So what we're going to look at, types of construction materials. We'll look at the 5 types of building constructions. We'll look at describe the effects on fire on the 5 types of constructions that we have. We'll look at building components and how they affect us, in fire or as firefighters. We're going to describe the hazards that the buildings under constructions or demolition can pose to firefighters. And then in the end, we're going to look at how building construction factors into pre-incident planning and also the incident size up. So here we go. So building construction, it affects how fires grow and spread. And you can see from the picture there, that was in Nairobi in 2009 in January when that Nakumatt fire was there. So firefighters, we need to understand how each type of building construction reacts when exposed to the effects of heat. This can help us to know when it's safe or to determine when it's safe to enter a building and when to evacuate if it's necessary. Because again, we have to take care of ourselves. So we look at a couple of things. So we look at occupancy. So occupancy, as it says there, how is the building used? So it may be classified as a hospital, a church, a school, a factory, etc. So that would kind of give you an estimate of the number of people in there. If it's a hospital, you'd probably know there's a lot more in there. If it's a church, depending on the day, then you'd have a certain number of people there. So this should also be considered when you're responding to a fire. And then the contents also relates to the classification. If it's a hospital, then you'll have oxygen tanks, you'll have beds, you'll have probably a dining area, you'll have all those other things. If it's a school, you'll have desks. If it's a factory, you'll have heavy machinery, you'll have, that sort of stuff. So this is also very relevant to us when we are going to a fire. So it's good to know what the occupancy says, what's the building classified as, so that way we come prepared. Also, it might help you in kind of selecting what tools you might need for the task ahead. So similar occupancies can also pose different levels of risk, and we'll look at that as we go through the presentation. So then, types of construction materials. All right, so these materials determine the basic fire characteristics of the building itself. Now, some of the things we're going to look at, excuse me, is combustibility. This one pretty much means the capability of being burned. How fast does it catch fire and how easily does it burn? Then the other is thermal conductivity. This is the material. This is a measure of its ability to conduct heat, the material itself, right? So the heat transfers occurs at a lower rate in materials of low thermal conductivity than in materials of higher thermal conductivity. So those are just some terms there, but we'll discuss more of them as we go through the presentation. So decrease of strength at elevated temperatures. This talks about how different materials will hold up in the heat before breaking down or before failing. This is also important because if it is a roof or if it is a door or a wall, then we kind of gives us a rough idea of how much time we need to be in that area before we need to evacuate. Then thermal expansion when heated. As it says there, this is the tendency of a matter to change its shape, area, volume, or density in response to a change in temperature. If the fire is really hot, then again, we may have a problem in that area. So all these things are just a few things we should know about construction materials. So let's look at the different ones we have. So we'll look at masonry versus concrete. So we'll do some comparisons. So masonry says it's inherently fire resistive. That means it doesn't burn that easily. It's a poor conductor of heat. If it has openings in it, it can allow oxygen to get in, the fire can spread. With a prolonged exposure to fire, masonry can collapse. That means the wall can actually collapse. And that's just an example of a masonry wall. There may be different types depending on whichever part of the world you come from. Concrete, naturally fire resistive. Again, it's a poor conductor of heat. Strong under compression. That means as something is burning and it's getting compressed, it still kind of holds its form. But weak under tension then can be damaged through the exposure to fire. So that's our normal concrete wall that we have there. So moving along, we go to steel. Now, as you can see from the picture, the steel will bend. It's the strongest material in common use out there, strong in both terms of compression and tension. It will rust if exposed to air and moisture, like out here where I am. There's big problem with rust. So a lot of things get to rust. Vehicles will rust, pieces of equipment will rust if they're left out. Not fire resistive, that means it will burn. It's a very good conductor of heat. That means the steel can transfer the heat from one area to a different area of the building that is not burning. Expands and loses its strength when heated. Any sign of bending, sagging, or stretching indicates immediate risk for failure. So if you are in a fire that had, in a building that had a lot of steel structures on it, and you see it starting to sag, to bend, then you know chances are it's about to go or it's in the process of failing. So other metals that we have aluminum. Our American friends will say aluminum, but for today in Africa, we'll say aluminum. This could be like siding for the windows, the door frames, the door panels, and just generally like a pile of scrap aluminum. Copper is also used a lot for the piping and for the wiring. And then we have zinc. It's used as a protective coating for the metals, like on the tabs and other fittings, you'll have zinc on there. So these are some of the other metals that you'll have in our regular building constructions. So we look at glass and gypsum board. All right, so we'll start with glass. Non-combustible, but not fire resistive. If it's ordinary and untreated glass, it will break when it's exposed to a flame. So that's all there is pretty much to do with glass, not too much more we can go into that. But gypsum board, good insulator, it has limited combustibility. If it's got paper in it, it will burn, but the gypsum board itself will not. So it's often used sometimes in some buildings or constructions as a fire stop, but prolonged exposure to fire will cause failure. So none of these items we've talked about are really like 100% fireproof. At certain points, they may fail, right? So you might ask yourself, what's a fire stop? Now, fire stop, it's something that is designed to maintain the fire resistance rating of a wall or a floor assembly, something designed to impede the spread of fire or smoke. So it kind of is to slow it down. So like, as you see down there, the gypsum board, we have the normal one, we have the fire board, we have moisture proof, and we have waterproof. So they come in different styles or different types. Wood and plastics. So wood, very common, world over. Could be manufactured wood, could be human-made wood, could be composite wood. It may warp, it may contain toxic products, it burns and fails really quickly, right? Most important characteristic is the combustibility. Weakened when consumed by fire. So it ignites, it burns, it decomposes based on either the moisture, the density, preheating, the size, or the form of it. So high temperatures decrease strength via pyrosis. Now, pyrosis is wood that is subjected to a rapid thermal decomposition in the presence of oxygen. That is the term that is broken down as pyrosis. So that's what that means. So then we look at plastics. They're rarely used for structural support. Combustibility varies depending on the type, but most plastics will release dense or toxic smoke when they burn. Now we have different kinds. There's called thermoplastic materials. These ones will melt or drip. But what thermoplastic materials mean, these ones that can be softened through heating before being processed, then left to cool and harden. So that's what we call thermoplastics. Once cooled, they show no changes in their chemical properties, meaning they can be remelted and reused several times. So that's thermoplastics. Thermoset materials, those ones lose shape. They will not they will not melt, sorry. They are synthetic materials that strengthen when heated. So once they're heated, you cannot remold it again, or you cannot reheat it and then transform it again. So those are just kind of the two different kinds of plastic that we'd have. And some of this with the newer building materials would have them as part of the components of our building that would go into. So now let's look at the 5 types of constructions. Now, for me, this was quite a surprise because I didn't actually realize this different types of constructions. I always say a house was a house, a building is a building, but I guess you always learn something new. So there's type 1. So there's 5 types. So type 1 is fire resistive. Type 2, non-combustible. Type 3 is ordinary. Type 4 is heavy timber. Type 5 is wood framed. So we're going to look at each one of them and see what their characteristics are. So it says that it goes from type 1, type 2, type 3, type 4, and finally type 5. So we look at each of them as we go through. So type 1, fire resistive. Now, if a building is rated as a type 1 fire resistive, then all the structural components in it must be non-combustible. That means they cannot burn easily. They're often used for high-rise buildings or multi-storied buildings. And they should be able to withstand fire for between 2 to 4 hours. So that at least gives you some time to be able to get in there, evacuate, or attack the fire. So 2 to 4 hours before it actually starts to break down. The building materials should not provide fuel for a fire, because imagine if it was a high-rise building or multi-storied building and all the materials provide fuel for fire, then it will be failing very fast, or the structure will fail very quickly. If it has steel framing, it must be protected. And the fires of this type can be very hot and extremely hard to ventilate. So that's just an example of a high-rise building, and you see it's mostly a lot of concrete, so that doesn't burn easily. So that's fire resistive type 1. And also in extreme conditions, this kind of building may collapse. And we've seen it happen, in different parts of the world. Really strong building, but because of the excessive heat or extreme conditions, then the building will collapse. So that's just something also to keep in mind. So we look at type 2, non-combustible. Similar to type 1, but the building materials of type 2, including interior walls, the framing, roof extracts, they're all made up of non-combustible materials such as metal or concrete. Now, although these materials are labeled as non-combustive, they offer less protection than the type 1. So type 1 would be the cream. If we're looking at vehicles, if type 1 was the Mercedes, then this one is our second level. So they're usually not coated in fire resistant materials, so spreading a fire would likely do more damage. Now, buildings that fall into this type 2 category would be shopping malls, the newer schools, big box stores like Naivas, or Nakumat, Tuskys sort of thing. So, but then again, remember this type 2, it has 2 classifications, A and B. So type 2A, the exterior walls, structural frame, the floor, ceiling, roof must have at least 1 hour protection against fire damage. This is at least enough to get people out and, just give us a little edge over the fire. So that would be type A. Now type B, exterior walls, frame, and roof need to have very little resistance. So there's 2 types, so A and B. So most of the big box stores, like this one we have here in the picture, would be a group 2 of the A, type 2, but of the A variety, where it has the 1 hour protection against fire damage. So moving on to type 3, ordinary. Now the buildings that fall into this category have walls that are built with brick, masonry, concrete block, precast panels, or other non-combustible materials. But then the interior structures can also be wood framed. The main goal of this type 3 is, in case of a fire, is to contain the fire within the exterior walls of the building and prevent it from spreading to nearby buildings. Again, this one has 2 groups, A and B. So in type 3A, there's protected combustible. So the exterior walls have that 2 hour fire protection, and the rest of the building has 1 hour protection. Type B, the exterior walls have 2 hour protection, and the rest of the building has very little resistance. The construction options for this type of buildings, type 3, they are more varied than type 1 and 2. But then again, you still have less fire protection. So it's up to really us as firefighters to know the kind of buildings we have in our city or in our towns. That way it prepares us, even mentally, about what to expect when you go to fight a type of fire in this sort of structure. So let's look at type 4, heavy timber or heavy lumber, as they would say in other countries, right? So this is a building that mainly uses large beams of wood. Different countries, they have log cabins. You know, Canada, in America, in certain parts of the world, they have log cabins, so made entirely of big trunks of trees. Now, if you look at the older buildings or the barns or churches, you might see the big structural beams that are in there. And they're usually collected by metal plates, or they have thick bolts that go through. The columns, beam, or the girders will also be at least 8 inches thick to support the building's loads. And as it says there, heavy planks for the roof and floors might at least be 6 inches thick. So these type 4 buildings have also non-combustible exterior walls and interior elements, but they're not divided into A and B as the type 3s. Thick structure means they're more resilient to collapse, means they're more steady, right? But again, they don't do well against the fire, because they'll do well, right, against the fire, because the materials take longer to burn. It's like trying to burn a whole tree trunk. It takes a while before it catches fire. But again, like it says there, you will need a large amount of water to extinguish that fire. So it's just good to know what you have in your area. Like we always say, be prepared, and then you'll not be too surprised when you get called out to an incident or to a fire. So that type of building is that this is the kind of becoming popular now, because a lot of people love all the natural style of buildings. So a lot of people are going back to building the or wood or lumber type heavy timber for their buildings. Makes it look nice, makes it look greenhouses sort of type thing. So you'll see a lot more of that coming through. Then we look at the type 5 wood frames. As it says there, they're the smallest buildings, such as single family residential homes, restaurants, or even small office buildings. The material for this type can be anything allowed by building regulations, but it's usually wood. Now, this one also has 2 groups, A and B. So group 5A is a frame, load-bearing floors, walls, and roofs must use fire-rated materials. This is seen in older construction, but it's rarely done today. And the type B of this building, no required fire resistance rating for any of the building elements. It's the only type of construction that allows for combustible interior walls and structural components. Again, these buildings are most budget friendly, but they do come with safety and space limitations. So it would, according to the standards set by the International Building Code. So as you see there, they're easy to make, they're affordable, but in a fire, then it would be very easy for it to collapse, because again, these are what you'd find in a lot of the informal settlements, a lot of the wood structures you'd find there. So that's again just something for us to note. So now we look at, still in the building components, how the various components function will improve our safety as firefighters. So I got this little sort of chart here. So in one, it says fire protection features, and we look at the exit parts, the active fire protection system, type of occupancy, fire design. So this is pretty much for us like a guide that we can use when we're looking even at a building. Then we have number 2, regulation and enforcement. That's for us to do as we go and do the inspections. So as we do the inspections, we're looking to educate the public on what they can do better to keep themselves safe. Just remember, when you do your regulation and enforcement, you have 2 ways. You can either go to the way where you go heavy-handed and you write everybody a citation, or you write everybody a fine. Or you can go the way where you're more proactive, meaning you're more towards education rather than just fining everybody for every mistake they make, because assuming not everybody knows, what they may think is normal may not be actually up to code. So it is our duty to educate our members of the public and let them know this is what they can do, right? So that would fall under part 2 of that one. Then there's part 3, we have common sense, civic sense. So this is where we do our fire safety awareness, evacuation drills right away for the firefighters. So we need to make sure that the places that we go to, we have a place where our fire equipment or our fire tenders can get to. Because if you can't get your fire tender to the fire, then you're not going to put off the fire. Then again, that results in other problems. So this is where this part comes in. And then part 4, we're looking at technology and firefighting resources, where we look at our response time, if we have volunteers, do we have emergency preparedness for that sort of areas. So these are different things that we can adopt and we can look at to make our work easier, right? Because if you went to a building and they had a fire and everybody knew to evacuate the building and shut the doors based on what you have told them, then it would kind of help you when you come there. And by the time you get there, tell you, we've already evacuated the building, everybody's accounted for, we've shut all the doors, we've done A, B, C, D. It does make your work easier. So, excuse me, that's just something we can think about as we go forward. So, let's look at foundations. Foundations transfer the weight of the building and its components to the ground. So it ensures the building is firmly planted. And we all know that a weak or a shifty foundation can cause a building collapse. And unfortunately, many firefighters have been killed as a result of this happening. So we need to understand the buildings in which we fight our fires. The knowledge of this building construction starts with understanding the load forces and the materials. Pretty much as you look at a building, as you're driving down your daily commute, you're coming from home, this is your area you live in, come from home, look around, see what's going on around you, because this early detection also is very good. So as it shows there, we have different pictures of people doing construction, and also as a result of foundations collapsing. So this becomes a really difficult situation for any firefighter, and you really don't want to be in a situation like that. So we become part of the solution, not part of the problem. We help the public to understand why they need to do certain things. But then again, you see that all doesn't fall on us. The different government agencies that are also tasked with doing the same things and making sure things are being done up to code. But that's a story for another day. So as we go on here, we look at the floors and the ceilings. So there's some buildings that have fire-resistive floors. It's a floor ceiling system designed to prevent the vertical spread of fire. So in the space above the ceiling, if it's not partitioned or protected, the fire can quickly extend horizontally. So for example, if this was the floor, the one to the left, just your regular wood, and then after they've put some insulation on it, then it kind of keeps the fire bottom and doesn't allow it to spread too far. So we look at wood supported floors. Heavy timber floors can contain a fire for an hour or more. Conventional wood flooring burns readily. Pretty much it burns like a matchstick, and it can fail in as little as 20 minutes. So our informal settlements, this is the situation we might be dealing with, the conventional wooden flooring. So modern lightweight wood beams and trusses. Trusses are pretty much that A-frame you have in your house. If you look up to the house on the ceiling board, the corner that supports your roof, that's your trusses over there. They offer very little fire resistance. And these are just other pictures of the same thing. So when you look at roofs, they are not designed to be as strong as the floors. And there's 3 designs. There may be more designs, but for this purpose, we'll just look at the 3 designs that we have. So we have pitched roofs, we have carved roofs, as you see over there. Then we also have the flat roofs. So you have your flat roof, you have your pitched roof, and then you have your carved roof over there. Those are the different types of roofs we have, and they relate also very differently in fires. So pitched roofs, they may be sloped or inclined. They can be a gape, they can be hip, they can be the different styles. Those are pretty much the different names for the styles of pitched roofs that are there. Usually supported by rafters or trestles, and they require some sort of roof covering, iron sheets, tiles, etc. So those are the different types we have of the pitched roofs. Carved roofs, used for large buildings that require large open interiors, warehouse, factory, automotive showrooms, things like that. So those are the different types. So that's your carved roof. And then the other side, we have a pitched roof, like residential houses and that sort of thing. So still on roofs, flat roofs, they'll have a slight slope for drainage. Wood support structures are solid. They would have wood beams or joists. If they have the open web steel trusses, these are often used for support. And then most of the covering is highly combustible. So that would be a flat roof over there. Now, ventilation may involve cutting through many layers of roofing to get to ventilate the fire. So as we said before, the truss is the framework that supports something like the roof, or even if you look at a bridge, that framework of it is called a truss. So it could be a steel beam, could be a wooden beam, could be that sort of thing, but they call it a truss. So look at our trusses. As it says there, triangular geometry creates a strong rigid structure, usually prefabricated wood or steel. They fall into three types. I just picked these three, but there's a lot more different styles. So there's the parallel cord, the pitched cord, and then there's the bowstring. Under fire, they provide little margin of safety. Failure at one point produces failure for the entire truss. So the whole truss will fail. And these are the different pictures that you have. So you've probably seen them on bridges, you've probably seen them in factories, in buildings. It could be either steel, it could be made out of wood. So these are just different kinds. There's 1,000 more different styles out there, but just for these purposes to give us an idea of what we're talking about, then this is what we have. Now they say the steel trusses are prone to failure during fire. So if it's, for example, a 100-foot beam truss, it can elongate or stretch as much as 23 centimeters when it's heated to 1,000 degrees Fahrenheit, which is 538 degrees Celsius. And in some fires, it may well exceed that amount of temperature. So this could happen, right? So always have to be prepared for the inevitable. So now we look at walls. Most visible part of a building, they're constructed of a variety of materials. Then walls are supposed to be load-bearing, non-bearing, and we look at the difference between the load-bearing and the non-bearing walls. They could also be specialized. So let's start with the load-bearing walls. They provide structural support. They're either interior or exterior walls. They support both the dead load and the live load, and we'll see what that means over here shortly. So looking at that structure, the outer walls are load-bearing walls. The inner wall that touches the roof is also a load-bearing wall. So if there's any wall that doesn't touch any part of the actual structure to support it, that would be a non-bearing, but we'll look at that shortly. So damaged wall can result in collapse. So if any of the sides, the exterior walls or the interior one that's holding the roof collapses, then it may lead to collapse of the structure. So that is a load-bearing wall. Then now I'll put them side by side so we can see them. So non-load bearing walls support only their own weight. They can be breached or removed without compromising the structural integrity of the actual building itself, as it shows like there. So the one with the red and the blue, the reds are all the load bearing. The blue has no load on it. And as you can see on the other picture with the house, the outer walls are load bearing, and then you see the inner ones that are slightly different colors are also the non-load bearing walls. So that just gives us an idea of what the load bearing and the non-load bearing walls are. And they could be either interior or exterior. Then we have specialized walls, what they call party walls. Now, this doesn't mean that if you're going to be having a party or you have a club, then you put on you make a party wall. That's not what it means. So it's a common wall to two properties. They would say some types of buildings share one wall. So you have a neighbor on this side and you have a neighbor on the other side, but you have separate roofs. So they're mostly always load bearing, this kind of party walls, and it often will be a firewall, right? So what do firewalls do? They're designed to limit the horizontal fire spread. They extend from the foundation through to the roof. They're constructed of fire-resistant materials. Then we have fire partitions. So all these ones we are naming fall under the specialized walls folder, so to speak. So fire partitions. So we have party walls, we have firewalls, and then we have fire partitions. These are interior walls that extend from the floor to the underside of the floor above. Then you also have fire enclosures. These are fire-rated assemblies or vertical openings. Then also there is the curtain walls. Non-bearing exterior walls attached to the outside of a building. Now, some of these specialized walls, most of the airports now have them. So if there's a fire in one section of the airport, they could shut these walls and contain the fire to that particular section of the airport. So it doesn't allow it to spread, or it takes much longer to spread. Others will have things like fire doors and stuff that we are going to come to shortly. So doors, windows, fire doors, and then fire windows. So doors, pretty much we use them every day: entry, exit, light, and also for ventilation. Could be constructed of wood or metal or a mixture of the two. Now, hollow core wood doors have little fire resistance, or they offer very little fire resistance. Solid doors provide more fire resistance. Solid core doors, like the older style doors, those ones are very good for in the fires. Metal doors are more durable and fire resistant. Then we look at the window assemblies. Again, used for light, ventilation, entry, and exit. And then the window type will depend on a variety of factors, your budget, the type of building, the design, the size, the materials you're using. Then fire doors and fire windows, like we had talked about, they're constructed to prevent the spread of flames, heat, or smoke. They must meet a standard. In the US, it's the NFPA 80, or in Kenya or other countries, we'll have a relevant country codes that govern the manufacture or the construction of this type of fire doors and windows. And you can find that a lot of the new high-rise buildings now, they will have fire doors, they will have fire windows, right? So in the fire door, might be a small fire window where you can observe what's happening on the other side, so you can see through it, right? They must be labeled accordingly, right? Because there's no point having a fire door and nobody knows it's a fire door. It will not serve its purpose at all. So fire windows are used when a window is needed in a required fire resistant wall. So it allows you to observe what's going on. So these are some of the stuff that can be added to a building to make it safer for us as firefighters, safer also for the occupants, give them at least some time to evacuate the building. So we're going to look at some of the interior finishes, things like manufactured housing, buildings under construction or demolition, because this all, again, put us at risk if we're not aware of the materials there or the components in there. So finishings and coverings are the exposed interior surfaces of a building. We should know the hazard posed by different interior finishes. Some are made from plastic, some are from petroleum products. Why is this important? Because if it's plastic, we're talking now about the toxic smoke. If it's petroleum, again, we're looking at the different hazards and carcinogens that may be derived from these materials when they start to burn. And remember, we're inhaling it, and we have talked about cancer and all that. So we need to be very, very careful when we go into such buildings. Now, manufactured housing is a newer type of style coming in. Other countries, it's been there forever, but they've been mobile or modular housing, or what they would call container homes. They're made of lightweight building components. Most of the components there, unfortunately, are combustible. So the death rate in mobile home fires is 3 times that of the other types of single home fires, because it will burn extremely, extremely fast. Right. So buildings that are under construction or demolition, this could be a special problem for firefighters, right? So it's something that we always have to, if it's under construction or demolition, we always have to be extra, extra careful. As you can see, if it could be construction and it starts leaning and you called it there to check it out, always be extra, extra careful. Observe your building before even trying to enter into the building. If you can observe it from a distance, even the better, right? If it's going under demolition, they may have taken off some of the load-bearing walls, which can lead to an imminent collapse. Normally also in such buildings, the built-in fire protection features are often missing or have been already taken out. Fire resistive enclosures, if they had any of that sort of material in there, that's already been taken out. And then often they've been unoccupied for long periods of time. So people also may have dumped trash in there, which would again be a sort of fuel again for the building when it's burning. So that's something again we got to look up and take care of. So pre-incident planning and then incident size up. Now we talked about this last week, but it's still very important here because this is part of something we'd need to do as a fire department to prepare us for our work ahead. So what does it do in these terms of building construction? So in terms of building construction, how does pre-incident planning and incident size up relate? So first of all, it provides a level of preparedness, far more comprehensive than sizing up the environment as the engine comes to a halt. So we have done it in advance. So even as you're approaching it during a fire, it gives us now that added advantage that we have already looked at this type of structure and we have an idea of what to expect. So another thing is a proper documented and updated pre-incident plan gives the incident commander everything they need to know in the first 5 minutes on the scene. So the quicker you attack the fire, the better it is, right? But this can only be done if you have already pre-planned. If you haven't pre-planned it, then you'll take more time to, to gather the information you need and to figure out which way you're going to go. So another thing it can do, it can bring to the fingertips virtually all intelligence that can be discovered about a site prior to an incident, because you've checked it out. So you have an idea, where the exits are, that window is probably blocked, or that's all that good stuff. So it's good that we invest the time and the effort into pre-planning, because the benefit that we'd get in terms of safety, in terms of saving time, will be a lot. As it say, it can come back tenfold. So we'll actually benefit more from being proactive rather than being reactive. So also, it enables you as a department or you as firefighters to train more effectively and then shed light on the things that you need to fix, your vulnerabilities. Say, we need to fix this, we need to get ladders, we need to get more tools, we need to get more, window breaking tools, we need to, anything that you need. You would only discover it if you train. So as you train in your pre-planning, then again, you're getting very well prepared. And then also, we are learning the general characteristics of the building types in your area. Know what you have, know what type buildings you have. Do you have a type 1? Do you have type 2? Do you have type 3? Do you have type 4? What do you have in your area? If you can, take a walk, introduce yourself, walk through the building, share knowledge, see what is there. Also, this is our time when we also learn about the new things that have come out in technology that are, geared towards preventing fires or slowing down the spread of flames in buildings. So this is our chance that we can get to explore and also connect with the community. And then also, we need to keep up with the changes in construction. So many things are changing. New materials are coming out, new styles. So the old standard way of building buildings has kind of changed. There's new designs, new ways of doing things, new materials that they're putting in buildings. So we need to know, how does this affect us in a fire? Is this new material they're putting, does it burn too quickly? Does it produce toxic smoke? What does this thing do and how can we tackle it? So it's also a very good way of learning new things. As we say, as a firefighter, you never stop learning. You're always learning new things, and you should not be shy about learning, because there'll always be something new to learn. Again, after all is said and done, it's not possible to pre-plan every property. There's some you may never get to, but you may have buildings that are similar, right? So if you have buildings that are similar, then you don't have to go to each and every building in that area. Of this type buildings, we have this number. Of this one, we have this number. So it kind of gives you an idea. So I put there, just keep calm and do your scene size up. Ultimately, valuable intelligence in a pre-planning plan empowers firefighters to make quicker and more impactful decisions that lead to better outcome for everybody on the scene. It would be nice if you'd go to a scene, you don't lose any lives, all your firefighters get back to the station in one piece. You know, that would be the ultimate outcome of that. And this can only be done if we are constantly learning new things, being proactive and going out there, not just waiting at the firehouse for a fire, then we get to go out. So in summary, this is what we've looked at: the materials used in building construction, how each material reacts differently to heat and fire, using a structure's occupancy classification. Firefighters can predict who is in the building. Also, we've looked at why firefighters must understand the basic types of building constructions. And then we looked at the 5 types of building construction, and then looked at each has their own strength and the weaknesses and the differing levels of resistance to fire. We also realized that buildings will contain a variety of parts and components. These ones can be made from different materials, and each one reacts differently to a fire. So we must take time to learn our area of our operation to enable safety and ease of operations. So down here, we have a picture of the firefighters from different countries. So the top row, as it says, there's Kenya there, firefighters from Taita Taveta. We have firefighters from Ghana. We have firefighters from South Africa. That's the top row. Second row, we have firefighters from Lusaka, Zambia. We have those from Malawi. And then finally on the bottom, we have those from Nigeria. So I'll apologize in advance if there's a country that I've not included here, please let me know. All right. Again, and then finally, stay alert, stay alive. Every firefighter's lives matter as we are committed to the community. And then just as we close, all the material that I've used for this is available online. So it's something that, you know, on your own time, you can go and do more research about it. It's available online and it's to our benefit to learn more about it. So thank you very much. And back to you, Mike.
Thank you very much, sir. Very much appreciate that. Very well done training session there. At this point in time, we will open up the floor for some questions, and let me let you guys unmute yourselves. You can raise your hand, you can unmute yourself. Just a couple of quick points to make as I was taking some notes and listening to you there. When you talk about load-bearing walls, your load-bearing walls you can sort of quickly identify by whether they're parallel or perpendicular to your roof trusses. So if your load-bearing wall is parallel in the same line as your roof trusses, typically that's going to be a non-load-bearing wall. But if your trusses are running this way and you're perpendicular, that's typically your load-bearing wall. So there's a kind of a quick way to identify whether your wall is load-bearing or not. It's important if we need to breach that wall or something like that. You talked about fire doors and identification of fire doors. The location of that identification on your fire door is going to be on the thin section of the door on the hinge side. There should be some kind of a plate or identifying thing there that tells you that it's a fire door and gives you the hour burn rating for that. So you'll see those especially in your commercial buildings. So when you're going through, you know, open that door and look in there in that hinge size and see if it's got one of those plates on it, that it's truly an approved and official fire door. And then the manufactured homes you were talking about, the mobile homes, I don't know how much you guys are seeing those. You'd mentioned the death rate is so much higher in those with fire deaths. And a lot of that is basically just sort of the design of that. Here we call a mobile home or what we call a house trailer. In the fire service, you call those a horizontal chimney, right? Because they're basically just one long hallway with your rooms kind of off the sides of them, and just the way they burn, they funnel the fire right through them, and that's what leads to that increased death rate that you talked about. So awesome, very good information. Any questions that we have out there with regards to building construction from the crowd there? Go ahead, Samson.
Good afternoon today.
Hello.
I can be heard. Good
Yes, sir.
afternoon.
Yes, sir. Go ahead.
Thank you very much, James, and thank you, Mike. I really appreciate this lecture. It's a very superb, very, very educative and very direct. I appreciate it. My concern in this building construction has to do with the way we look at rules and regulations in handling structures, buildings in Africa and maybe particularly in Nigeria. You know, when we want to build in this country, it is so unfortunate that firefighters or fire service are not involved. I think it's so essential in building construction that from the foundation, firefighters should be involved so that we can recommend the suitable materials that will be needed in order to protect their buildings or structure. Unfortunately, rules are not taken. Like from what James was saying, when he's talking about combustible materials, I realized that there are a lot of shopping malls that are built that even within a twinkle of eye, fire can consume, and which is not supposed to be. So I think being firefighters are taken along when they are building these structures will have recommended properly. We have a case in Nigeria sometimes last year, last year and upper year, yeah, some of these shopping malls were consumed with fire to finish from up to arches. And I don't know if there can be a standard or universal standard that can be put in place to regulate and instruct and direct building construction so that it will help firefighters in their operation or in their activities, maybe from the foundation to its finish, so that when firefighters want to go to a structure, they will know that, okay, this particular structure truly is built with these materials.
Very good point there. James, what do you think?
Yeah, I think Samson does raise some very strong points there. But unfortunately, you see, in Africa, our biggest problem is corruption. So you have where people are supposed to build house according to certain codes. There's the government agencies who are tasked to make sure that the building is supposed to go according to code. You know, the plans are supposed to be vetted. They're supposed to be approved before the building starts. But you can find even the most recent case last week in I think Nairobi or outskirts of Nairobi, some building there, 5-story building, all the occupants had to be evicted from that place because it had started to sink and there were cracks on the walls. But you think this is a building that was vetted, supposedly vetted and approved for construction. So that's kind of like the biggest problem we have. And apparently it's just not only Kenya, it seems to be an African thing, an African problem. And what I would suggest personally is as firefighters, this affects us the most because we're the ones who are going to die if we go into such structures. We may need to start doing those partnerships where, because you may find that people are not even aware that there's things like this, or firefighters can actually tackle such problems, or firefighters can assist or advise in such situations. So I guess it doesn't hurt to pay a visit to the local, planning office or the local licensing place and say, hey guys, if you're going on your inspections, take us with you. So, we can give a few pointers there, because I always assume all they can tell you is no, but it wouldn't have hurt. You'd have put yourself out there, and if you get the right inspector, the right person, then they'll really appreciate the extra help, and that way we can slowly start getting our input into the process. But that's some really good points there from Samson.
Yeah, the important key to that is the advocacy portion of it. There is an international building code. it's adopted in the US in a lot of jurisdictions that use the International Building Code, although there are changes that are made to it. Specifically, in the state where I'm from, while they adopted the International Building Code, the portions that talk about residential fire sprinkler systems are exempt, and you don't have to follow it, which is something that in the fire service we were trying to push for. But that sort of corruption that you talk about exists in different ways everywhere. And here the labor organizations and the advocates for home builders advocate against residential sprinkler systems because of the cost of construction. So those sections get exempted in a lot of places. So there is that International Building Code, although there would need to be exemptions just because there's some of the stuff that's required in those aren't necessarily available where you all are at. So there's that advocacy. And then taking action on your own is that when you see a building being constructed in your area, is to stop by, and if nothing else, while you may not have a say in how it's built, you can check it out while they're building it. You can look at the way they're doing it and help you begin that pre-plan on your building before construction's even completed. As you're looking at the bones of that building before they've closed things in, you can see where they're putting firewalls. You can see the type of construction. You can know, hey guys, if this building catches on fire, this is a firefighter killer, right? Based on the type of construction, we know when this is exposed to fire, bad stuff's going to happen. So you start to do that. So it's everything that we advocate for, that we try to push you guys to do, is that advocacy and speaking up for yourselves. A great topic today. At this point in time, we're going to pause our official portion of the training. I see there's still some other questions, and we'll get to those. Let me just wrap things up quickly by saying thank you to James for coming. We love having a local instructor. We hope to see more local instructors. If you're out there watching this live or watching this later on when we upload it to YouTube and you're interested in leading a training, please reach out to me. You can reach out to me at mike.kull@africafiremission.org or Leah, Leah, @africafiremission.org. Send us an email. Tell us you'd like to be an instructor, and we'll vet you and make that happen for you in any way that we can. We much appreciate you taking your time, spending your bundles to come here and join us today. As I mentioned, you'll see these uploaded onto YouTube later on today, and in the chat we'll provide you with some information on how you can obtain a certificate of attendance from our Google Drive classes. Thank you so much for your time, and please join us again next week.